let f is given by square root of 3x plus 4 and g is 2x squared minus 3. Evaluate the following functions. So f circle gx, that is called composition of f and g. Okay, it's not a product. So by definition, this is same as f of gx. Okay, f circle gx is same as f of gx. So pretty much plug in g into f. So g is given by this here, okay, 2x minus 3. That's the 2x minus 3 here, and we need to put this here. Okay, now this is input for f. So let's write that. So let me write one extra step. So f of gx is here, right? So let's write that. F of 2x squared minus 3. Now we need to think this as whole as input. F of some input, let's say something, I don't know. We can write it as x or some input, let's say box. F of input is here is given. F of x is square root of 3x plus 4 is same as saying f of any input is 3 times input plus 4 square root of 3 input plus 4. I mean, this is how it works. So f of input is then using this square root of 3 times input, 3 input or 3x, x is whole thing here, 2x squared minus 3. So we got two terms, so we must put parentheses around. So 3 input plus 4. So all inside the radical sign. Okay, this is it. That's the f circle g, but we can simplify here. And this is 3 times 2, 6x squared minus 3 times 3, 9 plus 4. 9 and 4 are like terms, so we can combine them. 6x squared minus 9 plus 4 is negative 5. Okay, do not cancel x squared radical sign. And this is it. Okay, let's do part B. Here, let me erase this because this is just the input. F circle f of 0. So this is by definition f of f 0. That means find the value of f 0 and plug that into f function. So f 0 means f of input 0. Now we need to go here. F of 0 means 0 is input, 3 times 0 plus 4. So let me evaluate that. So f of 0 is 3 times 0 plus 4. 3 times 0 is 0 plus 4 is 4. Square root of 4 is 2. So f of 0 is in fact 2. Okay, f of 0 means just simply replace x by 0. Now we are getting f of 2. Repeat the same thing, but now the input is 2. F of 2 is then, so here this value is 2. F of 2 is 3 times 2, 6 plus 4, 10, square root of 10. So this is square root of 10. And 10 is not a perfect square, and it does not have any perfect square factors. 5 times 2, 10, but nothing. So then this is it. So you leave here. Okay. Let's do part 3 here now. Oh, it's already given in g of f of x. So pretty much plug in fx or f function, plug in here to g. So our f is here, f 3x plus 4. So we would just plug in here. Okay, and the whole thing becomes input. So we need to read in this way. G of x is 2x squared minus 3 is same as g of input is 2 times input squared minus 3. Okay, so let's do a couple of steps here before we. So pretty much plug in f plug f into g. Okay, all that means. So g of fx is g of fx. Fx is given here, square root of 3x plus 4. Now this is now g of input. Okay, whole thing is we can think as x, g of x, or g of input. G of input is 2 times input square minus 3. So this is 2 times input square minus 3. Input is the whole thing, radical or square root of 3x plus 4. Here square root we can cancel. That leaves 2 times quantity 3x plus 4 and outside minus 3. Now we need to simplify, for we can distribute this. So we get 6x plus 8 minus 3, that is 6x. 8 plus minus 3 is plus 5. Okay, these are unlike terms, can't combine, that's it. Now part 4, that's the g of, okay, this composition g of f of negative 1. So g of f of negative 1. So we find the value of f of negative 1 and plug that into g. Okay, so here comes the function. F of negative 1 means this x is now negative 1. So 3 times negative 1 plus 4. So f of negative 1 is from here square root of 3 times negative 1 plus 4. What is that? 3 times negative 1 is negative 3. Negative 3 plus 4 is 1, positive 1. And the square root of positive 1 is 1. Or this value is 1. So we can sometimes do in your head, this is 1. So this is simply g of 1. Now we plug 1 into g. So g of input is 2, input is square minus 3. Now input happens to be 1. So 2 times 1 is square, which is 1, minus 3. So 1 is square is 1, times 2 is 2. 2 minus 3 is negative 1. Okay, final.